Yeah. So in today's lecture, we are going to talk about uniform rectilinear motion. We'll be talking about what is uniform accelerated motion, and we will be just discussing what is simple harmonic motion, but we will not be practicing simple harmonic questions today because I believe that the topic is quite lengthy and I need to make certain adjustments in the timing hours for the next week also, or maybe I will record the lecture and send it in the group or on the website. We will see. But today we are gonna deal with a lot of examples because those are important. Practicing questions in kinematics is important. So yeah, so let's start. So let's start with what is uniform rectilinear motion. Uniform rectilinear motion refers to a motion in a straight line where object moves at a constant speed. So we simply need to remember that rectilinear motion is linear motion. Yeah, this is straight line motion. So a body will always move in a straight path. So wherever the word rectilinear comes, you have to be make sure that rectilinear means straight path. And in this rectilinear motion, we are today talking about uniform rectilinear motion. So in this uniform rectilinear motion, there will be a constant acceleration, or rather, yeah. So in other words, the velocity remains unchanged due to the motion, meaning there is no acceleration or deceleration. So you have to remember that uniform means there is no acceleration or there is no deceleration in the body. So I hope the uniform rectilinear motion definition is clear to all of you, and it's a straight line motion. So there is nothing more to remember in this, and we will be dealing with the examples now. Okay, let's discuss what are the important characteristics of uniform rectilinear motion. So very first thing, as I told you before, that the object moves in a straight line. Second thing, the speed of the object remains constant. So the velocity will always remain constant. If it is 10 meter per second, so it will remain 10 meter per second only. Thirdly, the velocity is constant both in magnitude and direction. Again, the same thing. The last thing is the acceleration is zero here. We have to remember the acceleration is not constant but zero. So if I use the word constant, that is also true at some point, but it's better if we use acceleration zero here for uniform rectilinear motion. And for uniform accelerated motion, I will be talking about. So instead of using constant, or constant is the same means nothing, we can use also zero here, so it's better. So the acceleration is zero because there is no change in speed or direction. And that's it. The second important topic for today is uniformly accelerated motion. So in uniformly accelerated motion refers to motion when the object moves in a straight line and its velocity increases or decreases at constant speed. So the second thing is we have learned about uniform rectilinear motion and the velocity remains constant. Now we will be talking about, just need to take different pen. Okay, we will be talking about uniform accelerated motion. So in this uniform accelerated motion, one thing to know that the velocity will not be constant. So here the velocity is not constant. The second thing is, yes, acceleration is constant. That is the reason I told you to use the word zero here. Here instead of constant, I will be using word zero because it's better for me to understand. So there is zero acceleration here. So uniform accelerated motion is there is an acceleration and no, I'm sorry, I just confused with the acceleration velocity here. There will be constant acceleration and velocity will be increasing or decreasing. The velocity might change. So uniform accelerated motion refers to motion where the object moves in a straight line and its velocity increases or decreases at constant rate, then the acceleration is constant. So one thing is clear here, that acceleration velocity will either increase or decrease and the acceleration will remain constant. Okay, so two things are important and we are clear with things. Now, the key features which are important to remember uniform accelerated motion. The very first thing is the object experiences constant acceleration, which means that if acceleration is 2 meter per second square, it remains 2 meter per second square. But with that acceleration, the velocity is increasing. The motion is in straight line and the velocity changes uniformly. The initial velocity is usually known and the object velocity increases or decreases at linear fashion with time. So we will be discussing whether it is deceleration or acceleration. According to that, the velocity will either increase or decrease. So in this uniform accelerated motion, we need to remember that two important things, and we already discussed that two important things are, the first one is the velocity will either decrease or increase, and the second thing is the acceleration remain constant. So I hope Until now, we are cleared with the concept of uniform rectilinear motion, that is URM, and the second thing, we are clear with uniformly accelerated motion, that is UAM. Okay, without wasting time, let's move to the third topic. Okay, let's do the difference between uniform rectilinear motion and uniform accelerated motion. So very first thing, motion of the object, motion in a straight line path with constant speed. Here the speed is constant, here the acceleration is constant. So remember. Second, constant speed or velocity throughout the motion, because there is zero acceleration. The year velocity changes at constant rate due to constant acceleration. Make sense? The third thing is zero acceleration, no change in speed. Here is constant acceleration, rate of change of velocity is constant. A straight line graph in a slope, for example, if we make a displacement time graph is this one. So there will be a straight line graph. Okay. For uniform, here it will be a parabola indicating accelerated motion. So we know the parabola is something like this. So this is the graph of uniform rectilinear motion, and this is the graph of uniform accelerated motion. Last example, the last feature I mean is a car moving at a constant speed on a straight road, which is the example of uniform rectilinear motion, and the example for uniform accelerated motion is a freely falling object under gravity assuming no air resistance. So whenever we throw something from a certain height, then acceleration is constant. We know that acceleration is always 10 meter per second square, that is 9.8 technically, acceleration due to gravity. We know that thing, right? So when we throw a stone from a certain location or certain height, then we know that acceleration is always constant, that is 9.8 meter per second square. But as soon as by the time limit, as soon as we see that it is going more and more, but the time is taking more, so the velocity increases accordingly. But if we take the same example of if I throw a ball from the ground to up, so we see that the velocity decreases, and just because velocity is decreasing at certain point, the stone becomes at zero velocity, and then it comes down again. So both of the possibilities are possible. The very first thing is, in the first case which I told you, that acceleration is constant but the velocity is increasing, and in the second case, when I'm throwing the stone from the ground, the acceleration is again constant because it's minus 9.8 meter per second square, and the velocity decreases. So now I will be choosing a random person so that they can give me a quick overview whatever I have explained regarding uniform rectilinear motion and accelerated motion. Okay, so let's choose Alvina. Could you please turn on your mic?
Yes, Assalamualaikum.
Walaikum assalam. Okay, so yeah, I can hear you. So
uniform accelerated.
Was that Albina? What is your question? Yeah.
Yes, sir.
Yeah, I was saying that I gave you just two examples of stone. Could you please explain what I mean by that?
When a car moving a constant speed on a straight line, then the velocity will be zero.
Okay, velocity will remain constant, you mean? Okay.
Constant, the velocity will be zero.
Not zero, but constant. If velocity is zero, then the car is not moving, yeah?
Yeah.
So you mean constant, correct?
Yes, ma'am. Yes, sir.
Okay, and for uniformly accelerated motion?
Give me 2 minutes, sir.
Yeah, take your time. Take your time till the time. Alicia, could you please turn on your mic? Alicia, if you're here today.
Yes, sorry.
Okay, perfect. Guten Morgen. Perfect. Alicia, can you hear me?
Yes.
Okay, perfect. So could you please explain me the example which I gave just now about the stone?
Yeah, I was just shortly in the bathroom. That's why I didn't hear it.
Okay, that makes sense. Perfect. Take your time. So Anyone who wanna
I
explain
just came back.
okay, you just came back. I'm sorry. So you missed an important topic. So anyone wanna explain what did I just explained with the help of stone?
So can I explain?
Yeah, Ravinder, go for it.
So yes, so for uniform rectilinear motion, if we are saying that a car is moving with a constant speed, so there is it means it's moving with a constant velocity also, and acceleration will be zero. And
Okay.
acceleration is zero, so there is no change in velocity.
Perfect.
Because acceleration tends to change the velocity and all.
Perfect. That makes sense. Yeah.
And for uniformly accelerated motion, we are saying the acceleration is uniform. That means it's constant. And if there is an acceleration, of course, there will be a change in velocity. It can be either deceleration or positivity.
Okay, for acceleration. So Ravinder, I just gave an example of a stone. When I'm throwing the stone up, what is happening with the velocity?
Yes, so the velocity is decreasing as
Okay.
acceleration is on the opposite direction.
Perfect, makes sense. And what is happening when I'm throwing a ball from a certain location or certain height?
Yes, at that time the acceleration due to gravity is on the same direction with the velocity, so it will increase the velocity.
Perfect, perfect. Thank you so much, Ravinder. And I hope this concept is clear for all of you. And now we will be doing real-time examples. But of course, the theoretical part should be clear in order to make sure that we are making the right decision while reading the question. Okay. So now let's discuss about uniform circular motion, and then we move forward with doing practice questions. So uniform, yeah.
So if we move in a straight line with a constant velocity, so there should be no acceleration, right?
Yeah, exactly. You're right. No acceleration, zero acceleration.
Yeah.
Uniform
Thank you.
rectilinear motion. Perfect.
Yes.
Yeah. So now let's move with the uniform circular motion. Uniform circular motion is very similar to what we have learned. So it refers to a motion of an object traveling in a circular path at constant speed. For example, the moving satellite around the Earth is the best example of uniform circular motion. And for example, your tire wheel is also the best example of circular motion. So the objects remain in speed. The speed of the object remains constant, but the velocity is always changing. And why the velocity is changing, let's understand it. For example, this is Earth, and this is the orbit, and this is my satellite. So when I know the speed is constant, but at every point this satellite will have different direction. Yeah, here it will be having different direction, here it will be having different direction. So at every point this satellite is changing its direction, and that is the reason we say velocity of the satellite is always changing. Velocity of the satellite is always changing. I hope this makes sense for all of you, why the speed is constant and the velocity is changing at every point. With the help of this diagram also, I made it here for you, because you see this satellite is going here, so direction is here, and now when it will be here, the direction will be here. That is the reason. So I already wrote here, the velocity is always changing due to the continuous change in direction. I hope that makes sense. Anyways, so the key features which are important is the object moves in a circle with constant speed. The very first thing, that is, speed is constant, but the velocity is changing again. The second thing is the object has a constant centripetal acceleration towards the center of the Earth circle. We know that the Earth is pulling the satellites towards itself, but the reason why the satellite is not coming inside is because it's in the orbit. But yeah, there is some acceleration from the Earth, which is keep going the satellite around, revolving around the Earth. And this is known as centripetal acceleration, which we discussed yesterday, the force which is acting towards the center. The last thing is the object velocity changes in direction continuously as it moves. As I already told you, the very important feature, the velocity always changes. Now, simple harmonic motion. I believe that I will just tell you what is simple harmonic motion right now, but we will not be doing any examples because it's a long concept, and I believe that I need to make a separate 1 hour video for this. So that is the reason I will be just telling you what is the definition, but we will not be doing examples today. So,
Hello.
yeah, hi.
Hi. Actually, could go to the previous slide, please?
Yeah, for sure. Go for it.
So the satellite would be changing its position, but then every position it passes through, the direction would be same, right? So why is the velocity changing?
Because the direction is changing at every point. Yeah, it's in this way. But if it is here, then it is way. But if you're asking that after coming here again at certain point, the velocity will remain the same as the previous one, yes, you're right. But of course, the direction is changing everywhere because you know that orbit is not linear or it's not perfectly oval. It is something ellipse. If we remember Kepler's law from gravitational.
Okay, so
Yeah, that is the reason. We just need to simply remember that the position is changing, and that is the reason direction is changing, and that is why the velocity keeps changing. Makes sense?
yes, sir.
Perfect, thank you. All right, so simple harmonic motion is the type of periodic motion where the restoring force is directly proportional to the displacement. So whenever I talk about the SHM, that is simple harmonic motion, I always talk about something like this. So well, just to remember right now, and I will be making a separate video again, but just to remember that this is only known as amplitude and this is origin and stuff. So here the force is directly proportional to the displacement. So the restoring force, the sign Y negative because of the restoring force. The restoring force is directly proportional to the, we write it like this. But when the proportionality constant disappear, of course you put a constant. That is why I put K. K is a constant. So here in simple harmonic motion, force is equals to the minus kx, and this is displacement. So the motion is oscillatory and periodic, means that it will keep going, coming like this. It will be oscillatory motion, and it is also a periodic motion. The best example of this is Earth revolving around the sun, or the satellite revolving around the Earth, because they have a perfect time that they come again. Alicia is having a question. Yes, go for it, Alicia.
Yes, could you explain again why it's negative?
Yeah,
I
for
didn't
sure.
get that point.
Yeah, for sure. The reason why this thing is negative is because it is acting in opposite direction. The force, this thing, that is, for example, if the displacement is happening in this place, then the force is applying in the opposite direction. That is the reason we put negative sign. And again, I told you before that I need to make a very brief and detailed video for simple harmonic motion, which I will be uploading very soon, so that you guys can understand the concept. But right now I believe that I will rather skip SHM and put a video, and you don't have to learn anything about it at the moment, or rather you can learn just the definitions and stuff. These are the, okay, Alicia, I hope the thing is clear.
Yes, thanks.
Yeah, the restoring force. So where K is the spring constant and X is the displacement. The force and this thing is opposite direction. That is why we put negative. But of course, I'm gonna make very detailed video on SHM, which I will be putting very soon. The centripetal acceleration we discussed yesterday, if you remember, centripetal acceleration is v square upon r. And if you remember this, I didn't taught you yet, and I will be doing it in next week. We are gonna discuss about Newton's law of motion next week. So in NLM, that is Newton law of motion, we are having three laws. So the second law says that force is equals to mass into acceleration. Mathematically, if we say, we're not discussing in very details right now what is Newton's law of motion, second law, first law, third law, we know it. But just to make sure that the second law says that force is equals to mass into acceleration. So in the same way, we know that acceleration, centripetal acceleration is v square upon r, right? Yesterday we discussed it, v square upon r. So in the same way, if I talk about the centripetal force, that is Fc, it will be mass into acceleration, and AC what? The acceleration, centripetal acceleration, that is why the centripetal force is written as mv square upon r. So this is the important formula which we have to remember for centripetal force. So I'm writing here Fc is equals to mv square upon r. And from where it came, I told you, from Newton's second law of motion. Newton's second law of motion says that F is equals to m into E, and since we are calculating Fc, we need to put the value of AC, and that is why we will get the answer for centripetal force. Here the m is mass of the object, v is velocity, and this thing. So let's do a question, and then let's move to more difficult topics, not difficult topics, but more conceptual questions which are more related to IMAT, so that we can more clearly understand this topic. So this question is, a car is moving around a circular track of radius 100 meter. I think I will. Okay, the question is, a car is moving around a circular radius of, a radius is given as 100 meter with a speed of 20 meter per second. The speed is 20 meter per second. They have asked about the centripetal acceleration. Yesterday we did something similar, but let's do it again. Acceleration, centripetal acceleration. So it is v square upon r. AC is v is almost 20 square upon r will be around 400 upon 100. 0 get cancelled, and the answer is 4 meter per second square. So now you can easily calculate, and if they say that the mass of this object was 4 kg, so you can simply say that Fc is equals to m into AC. Fc will be, mass is already, how much is it given? 4 kg. So I can write 4 here, and AC is what? 4. So the force will be 16 Newton if they have told you the mass. But anyways, they didn't told you, but I'm saying just an exception. So now you can easily calculate the acceleration, centripetal acceleration. Now you can easily calculate the centripetal force as well. So two things you can calculate now. Now let's move to some more examples which I believe are important. Perfect. Okay. Okay, for SHM I'm gonna the video. Okay, perfect. Let's start with the example. I wonder if I can write here. Okay, let me take a screenshot of this. Okay, let's do this question first. All right. Yeah. The question is, a car is uniformly deaccelerated. You can see the questions, right, guys? You can see the question.
Yes,
Yes.
sir.
Oh, perfect. Okay, thank you. So now here the question number 1. Okay, let's start with this. A car is uniformly deaccelerated means that it is getting deaccelerated, means that it is coming at some point at rest. Brought to rest. Okay, yesterday I told you whenever the rest comes, you need to remember it's 0. But now what is 0? You have to be careful. So since the car was already moving, so it was having certain velocity. So initial velocity was not 0 for sure. But now they have said it was deaccelerated, means that the car came to a rest. Now the car is resting. And now we know that the final velocity is 0. Since the car is resting, that is the reason v is 0 now. And u is given as 30 meter per second. So I can write u is 30 meter per second. And the total time in which it came rest was 15 seconds. So they have asked us the acceleration. And since we know that this was deaccelerated, the acceleration should be something in negative because it was deaccelerated. So we need the kinematical equation v is equals to u plus at. And in that v is 0. And why v is 0? You have to be very careful. Why I should write v as 0, not u as 0. Okay, this thing is important. Again, I'm telling you, just make sure u is 30, acceleration is I need to find, and time is 15 seconds. So 0, 30 plus 15, a will be minus 30 is equals to 15a, which will be minus 2 meter per second square. Okay, Amber, are you here today?
Yes, sir.
Yeah, Amber. So could you please tell me why is this negative sign coming here?
Sir, because it deaccelerated.
Perfect. Thank you, Amber. Thank you. Okay, let's move to the second question. This is a very brief question and we need to be careful about it. Let's do it because this is important and I think they can ask you in IMAT. Okay, so we need to just make sure, but we read the question carefully and we write the what are given. So let's start. A car accelerates uniformly from rest at a rate of 0. So from rest, so means I have u as 0 meter per second at a rate of 2 meter per second square. So you can see that the SI unit is given meter per second square. So you can say that it is acceleration, and whenever there is rate, you simply write acceleration anyways. So acceleration is 2 meter per second and time is 6 seconds. Okay, so a car accelerates uniformly from rest at a rate of 2 meter per second. Okay, makes sense. It then maintain a constant speed to for half a minute. Then the car is maintaining a constant speed for half minute. The brakes are then applied, and then the brakes are applied, and the vehicle is uniformly retarded. So now in the third stage it is getting retarded. So the first phase is this, the second phase is this, and it retarded to the rest in 5 seconds, and time taken is 5 seconds in the third stage. Find the maximum speed reached and the total distance covered. Okay, so anyone wanna try this question?
Yes, sir. Can I?
Yeah, please.
Is it 12 and 60?
Sir, can I help?
You already solved it, or you wanna solve it with me?
Sir, I solved it.
Okay, what is the answer?
I guess the maximum speed is 12 and the distance covered would be 60.
V max is 12 and the distance covered is 60. 60, right?
Yeah.
Perfect. Okay, let's check. So this is the answer from Tanisha, right? Okay.
Sir,
So
426.
what?
Total distance covered is 426.
Someone is saying 426. Okay. Any more? No. Okay, let's start now. So let's break the problem into two parts: finding the maximum height reached and then the time taken for the entire journey. So let's find the maximum height. Okay, maximum speed. I'm sorry. Yeah. So let's find the maximum speed. So you know that they have given you u0 this thing, so we can use the first kinematic equation and we say v is equals to u plus at. So v is what? 0 plus 2 into 6, v will be 12 meter per second. So Tanisha is right, it's 12 meter per second. V maximum is 12 meter per second. So v is clear. Now let's move to the maximum distance, the distance covered. So let's calculate the distance s1 covered. So s1 is ut plus half at square, and you know that u is 0, time is how much seconds they take? 6 seconds, plus half into acceleration is okay, 2 meter per second, and time is again the 6 seconds. So you can say that 0 plus half into 2 into 36, 2 to cancel, so s1 is 36 meter. Now we need to calculate the constant speed phase. This thing is a constant speed phase. So in constant speed phase, I will just okay. So the constant speed phase is they have said that our speed will, for now speed will be constant, now speed will be 12, where in the second thing, now in the constant speed we already know the speed is 12, so the speed will be 12, so v will be 12 meter per second. And the time taken, they said what in the question, the second phase,
Half minute
it then
is 30
maintains the
seconds.
constant for a half a minute, means 30 seconds. Okay, makes sense. So time is 30 seconds, and the distance we have to find. So simply you can say that speed is equals to distance upon time. So when it is constant speed, so you can use this formula. Speed is 12, time is 30, and your distance will be 12 into 30 is how much? 360 meter.
360.
Perfect. So now we know S2 is 360. So we calculated S1 36 now, and S2 is 360. Now let's calculate the final S3 when it is getting retarded. In this phase it is getting retarded, yeah. So we know that the acceleration vehicle is retarded in 5 seconds. So time is 5 seconds when it is getting retarded, and we know that the initial velocity was 12 because it was in constant speed, so u can be written as 12, and final velocity will be 0 of course, because the car, this thing is coming at rest. And now what they have asked us, the displacement, yeah. So we can use the formula, the same formula, but we need to calculate the acceleration here. V is equals to u plus at. V is 0, this is 12, acceleration we need to find, time is 5. Two point what? 2.5 meter per second.
2.4, sir.
Okay, sorry. 2.4 meter per second. So this is the deceleration, and now you know the deceleration, you can use the formula again, ut plus half at square. U is what? 0? Or no, it is 12. And time is what? 5? Yes, because they have told that in 5 seconds. Plus half, acceleration is minus 2.4, and the time is again a 5, right? So S3 will be 12 into 5 is how much? 60, plus half into minus 2.4, 25 square is what? 25. So S3 will be 60 plus minus 1.2 into 25. S3 will be 60 plus 1.2 into 25 is how much?
Minus 30.
Huh? Sorry. Did something wrong, yeah. What again 25 into 1.2. 5 0 1 5 1 2 2 3. Yeah, I did it right, yeah. 40, it's 40. So S3 will be 20. So now I know S3 is 20, yeah, if I'm not wrong.
Sir, minus 30. Minus 30.
The S3 is 30 meters, not 20.
Yes,
we should use the kinematic equation 2as is equal to vf square minus vi square, and then we will get 30.
Well,
sir, 25 into 1.2 is 30.
okay, is it 30?
Yes, it's 30.
Okay, perfect, thank you. So now our S3 is 30. So now we know the total distance is S1 plus S2 plus S3, 36 plus 360 plus 30, which will be equivalent to
426.
66, and it will be 426. Oh, you did it right. 426 meter. Okay, very good, yeah. So this is how it's gonna work. But I did a small mistake, I don't know how, but I need to 5210 22450 155 122. Yeah. Oh yeah, exactly. It's 3. I don't know why I wrote 20 here. Anyways, so this is the way how you will be solving. So I hope this question is clear to everyone. If not, please ask me, then I will repeat it maybe. Clear to
Sir,
everyone?
can you please revise it in a short brief?
Yeah, for sure. Why not? Let's do it. Okay. Okay, sorry. Yeah. So in the question, they have asked a car accelerates uniformly from rest at a rate of 2 meter per second square for 6 seconds. So we have to calculate for the first phase, and then maintain a constant speed. So we need to maintain a constant speed in second phase, and then it brakes are applied. Then we have to maintain the third thing. So we need to calculate S1, S2, and S3. Okay. And they have given conditions for each and everything. So let's start with the S1. So in S1, they have given us that initial velocity is 0 and acceleration is 2 meter and time is second. So we calculate the V. And we see that but when the car is reaching here, the velocity is 12 meter per second. So we know maximum velocity is 12 meter per second, which we already calculated. They have asked us the maximum velocity also, maximum speed. Okay. Anyways, so now let's move to the second thing, that it then maintains a constant speed for half a minute. So now we are going to part S2. So we know that half a minute is 30 seconds. So that is the reason we will be using initial velocity will be no, not this one. Okay, I'm sorry, we need to also find the we find it the speed, we need to also find the displacement for this one. So that is the reason I have calculated the displacement for S1. And you know that the car was starting from rest, so I put initial velocity 0, we put all the values, and we got 36 for the S1. Now we do for S2. So for S2, you see that the car is a uniform motion. So it is moving with 12 meter per second for next 30 seconds. So here we calculated it for S2. Where is it? Here. Yeah, where is it? No. Yeah, S2 is here. So we know that velocity was 12 meter per second and time was 30 seconds. Simply calculate the distance. That is because it is constant. You don't have to use any kinematical equation here. Simple. So you got 360 meter as S2. So 360 meter S2. S1, S2 is clear. Now we move to S3. S3, they have told that it is deceleration. And since there is deceleration means you have to put negative sign, and first we need to calculate the acceleration. The initial velocity was given as 12 meter per second and the final velocity will be 0. So when you put the value this here, you get acceleration as minus 2.4 meter per second square. And when you put the minus 24 or 2.4 here and put the initial velocity as 12 and put the time which they have given in the question 5, so you solve it and you get S330. And now you know S1, S2 and S3 will be the total distance. So you simply add them all and you get the answer. Does it make sense?
Yes, sir.
And you try solving this question by your own self also. I will put this question in the group so that you can practice it by your own self. And once you practice, you will be getting used to it. Alicia, how about you? Yeah.
Can I ask? Yeah, I'm not exactly sure. I mean, I understood the calculation process, but I'm not sure about the initial calculations that we use, why we choose exactly those.
Yeah, okay, makes sense.
Like, what are the keywords from which we know what calculations we should use?
Okay, so let's make it simple, you mean? Okay, we can do that. So in the very first step here, a car accelerates uniformly from rest at 2 meter per second. So this is a step 1. Okay, so let's do only step 1 first. So a car accelerates uniformly from rest. So rest is given, means u is 0. Okay, and acceleration is given, that is 2 meter per second. Okay, and the
Yeah.
time is given 6 seconds. So for the first condition, we know that u is given, a is given, and t is given, and we need to find the velocity. So we have only one equation which says that v is equals to u plus at, correct?
Yeah.
So v is 0 plus 2 into 6. So v will be 12 meter per second. I'm right?
Mm-hmm.
And this is step 1 for the when the car was from rest to moving to 5 seconds, 6 seconds, and having a constant speed. Now here the car is having constant speed. And now we have to also calculate the distance here. So distance is simple. You know that the formula, which one, v square is equals to u square plus 2as. No, just a moment. Now you know the velocity, that is 12 meter per second, and now you know the time, that is how much, 6 seconds. So you say simply s is equals to ut plus half at square. U is what? 0. Time is 6 plus half into acceleration is 2, and time is again 6 square. 6 plus 2 get cancelled. 0 into 6 is 0, so you get 36. So that is the reason we have 36 meter. And why we are not using v? Because it's still in process. This thing is attaining, it's here at this point is 12 meter per second, but till now it was constantly increasing. So for step 1, I hope this is clear.
Mm-hmm.
Yeah, let's move to the step 2. In the step 2, they have said that it then maintain a constant speed for half a minute. Simple. Okay, so we know half a minute is what? 30 seconds.
30 seconds.
Exactly. And we already calculate the velocity, that is 12 meter per second. And now the body is moving, so we know that the velocity is 12 meter per second. Now they have told us to calculate the displacement here. So simply we use speed is equals to distance upon time, because the body is in constant velocity. Speed is what? 12, and time is what? 30. So distance will be what? 12 into 30 is 36. My maths is getting horrible day by day. I'm sorry.
360.
Yeah. 360 meter. Yeah. So you know the distance for the second thing is 360. So now we need to finally calculate the S3. Okay, and now S3, we know that in S3 they have told us, again I will use different pencil, the brakes are then applied and the vehicle is uniformly retarded to rest in 5 seconds. So we know that time in S3, should I use this pen? Is fine, yeah. 5 seconds, yes. And the final velocity will be 0, because the body is coming at rest, and the initial velocity is still 12, yeah, because it went here, it became 12 for constant, and in the third step it from 12 to it became 0. So initial velocity is 12, v is 0, and now they have also told us that's it, yeah, perfect. So now we know that for calculating the speed distance, we need acceleration, and from where the acceleration will come, v is equals to u plus at. V is 0, u is 12, plus acceleration is we need to find, and time is 5. So 12 plus 5a will be minus 12 5a minus 12 upon 5 will be 2.4 meter per second square. So acceleration will be 2.4 minus speed per second square. Make sense? Yeah. So now since we have acceleration, we can simply use the formula s ut plus half at square. Now you must be assuming why we are not using v square is equals to u square plus 2as, yeah, because we have given with time also, that is the reason. In this we don't have time, and we need to put time, yeah. So s is equals to u is what? 12. Time is what? 6 seconds or 5 seconds? 5 seconds. Half, acceleration is minus 2.4. T is again 5 square. So now S is 12 into 5 is 60 plus that will become minus 1.4.
Minus 1.2.
Okay, 1.2 minus 1.2 into 25. S is equals to 60 plus minus 30. 60 minus plus minus is minus 30 meter. So yeah, so now we know the S3 is 30 meter. So simply add everything, S1 plus S2 plus S3, because they have to add the total. In the S1 it was 36, the S2 was 360, and the S3 was how much? 30. So when you
30.
calculate all, you get 426 meter. This is what it is. Clear? More clear, right? Alicia? No?
Yes, I think I just need to revise all the
you need to-
calculations.
exactly. You need to also revise, and you need to practice it by your own as well.
Yeah, I think it's just at first glance it seems like a lot. I think I just need to revise all the tasks
No,
that
no,
are
no.
similar, and then
Exactly. You will be fine.
To
Don't
get-
worry.
to get into the groove,
Exactly. Yeah, that makes sense. All right. So everyone is clear with this thing. Let's move to the another question.
Just one more question. You said there are many tasks in the IMAT that are similar to this one.
Yeah, some questions are very similar to this one. Yeah, but
Okay.
it will mean not that lengthy, but very similar. Yeah, we have to make sure that the concepts are clear, so that we can implement
Yeah.
in anything. Yeah. Okay. Let's do the other question. So in this question, we have an electric train moving at 20 km per hour. The reason behind bringing this question is because I need to make sure that you guys are good in conversion also. Alicia, make sure that you are looking at very carefully. Now,
The task. Oh,
this,
what do you mean?
This question. Yeah. Okay. So let's start with this question now. So they have told that an electric train is moving at 20 km per hour, accelerate to a speed of 30 km per hour in 20 seconds. Find the acceleration and distance traveled during the period of the acceleration. Okay, we need to find this thing. So very first thing, they have given that an electric train moving at 20 km per hour, that is initial velocity is given as 20 km per hour, accelerates to a speed of 30 km per hour. So you know that initial velocity is 20 km per hour. And final velocity is 30 km per hour in 20 seconds. Time is also given. Find the acceleration. The formula is simple. V is equals to u plus at. But now the important thing is they have given us in kilometer per hour, and we need to convert them in meter per second. So I have a very short trick for this thing. One thing is for sure, that we are going to use this formula to find the acceleration, no doubt. But before that, we need to make sure that we convert this thing. So initial velocity is 20 km per hour. So the simple formula is to multiply it with 5 upon 18. Ravinder, right? Ravinder is here or is sleeping?
Yes, sir, I'm here.
So can you say that I'm right, that whenever we want to convert kilometer per hour into meter per second, you simply multiply it with 5 upon 18?
Yes, sir, because 1 kilometer is equal to 1000 meter and 1 hour is equal to 3600 seconds.
Perfect. Thank you, Ravinder. Okay, so remember this thing, guys, very important, that whenever they have given you kilometer per hour, simply multiply it with 5 upon 18, you will get the answer in meter per second. So now I will just write it again so that you can clear. So initial velocity was given as 20 kilometer per hour. I need to convert it in meter per second, so I just multiply it with 5 upon 18. So I know this cancel at 9 upon thing. This will be 50 upon 9. Yeah.
Yeah, is it a U or a V
This thing,
that you've written? Yes.
it's U.
Ah, okay.
Okay. It will be 5.55 meter per second. Okay, initial velocity. Now let's calculate the final velocity. So final velocity is given 30 into 5 upon 18, 15, 9. 15 into 5 is what? 75? Not that bad in maths, come on. 9, 7, okay. We know that 9 9 is 81, 9 8 is something, yeah, 72, and it will be then 3 is left over here, and we can calculate 9 3 is 27, and then again 3 is left over there. Okay, so it will be 8.33 meter per second. Perfect. So we know the final velocity, and now we know the initial velocity in meter per second. So now we use the formula. V is equals to U plus AT. V is what? 8.33. U is what? 5.55. Acceleration is we need to find. And time is what? 20 seconds. 8.33 minus 5.55 is equals to 20A. 8.33 minus 5.55 will be what? 2.78. 20A. 2.78 upon 20 is equals to A. So when you calculate all this thing, you will be getting the answer 0 cancel 0 point, it becomes 0.278 upon 2, which gives you 1 3 is 6. So you get an answer of 1.39 meter per second square as acceleration.
So basically 0.14.
Oh yeah, approximately, you're right. So find the acceleration and the distance. Now we need to calculate the distance also. I hope everyone is clear why this 0.139 came. Yeah. So now simply we need to calculate the distance, and you know the formula for distance is S is equals to UT plus half AT square. Initial velocity is what? We have calculated initial velocity 5.5, and time is what? They have given the time, yeah. Acceleration we just found. Five 5.5 into 10 is 55.5, so it will become 110 something. Yeah, 110 something. I don't need to calculate, maybe. Yeah, plus half into 400. Uh, 0.139 into 100 will be 1.39. Okay, so I can write this as 200 into 0.1. There is a simple method also for sure, but just to make it understandable. 6. So your answer should be, I'm sorry, the point will be here, right? So answer should be 137.8 meter. Okay. Tell me doubts. Anyone is having doubt?
Sir, my answer is 139 meters.
Yeah, a little bit calculation is fine. Yeah, it's fine. It's not a big problem. Yeah, it can be so that also if we did some rounding off in that way. But that's fine. That will not be a problem. Okay. So any other problems?
Did you say 139?
149 answer you mean?
No, 139. Yeah, answer.
No, the answer is around should be around 138, 139 because I made a rounding off. So it should be
Yeah, all right. Yeah.
around 139, maximum 139.
I took approximate values, so yeah.
Yeah, for me the same. I did approximately as well, so that is the reason. It should be 138, 139, not more than that. Okay, anyone is having doubt in this? Laiba, how about you? Is it overwhelming? Not really. Laiba is in the class.
Yes, sir, I'm in the class. Actually, I'm doing the question. That's why I didn't reply.
You're not good. What did you say? You're not?
I said I was just busy with the question. So,
Okay, sorry. So you understood this question?
yeah, I completely understood it.
Okay, how about Minahil? Minahil is sleeping. Okay, no worries. Let's move to the other question. Okay. So I will give you time to solve this question. Now you guys can solve it. Question number 4.
So it's not visible.
Now?
Sorry, now it's.
Okay. Question number 4, please. All of you, please solve question number 4. Noor Fatima, please check question number 4.
Okay, sir.
Sir, acceleration due to gravity will be 9.8 or 10?
Take it 10 for now, is fine. I don't mind. But try using 9.8, but you can take 10 for now, just to make calculations more easy. Mehwish, Amber, I need answers.
So time is 1.4 second.
Time is what? 1.4 second. Okay, I
Four.
need to solve as well. I don't have the answer. Let's say, yeah, it should be 1.4. Okay. We will solve
Sir,
this.
maximum height reached is 10 meters.
Height is 10 meter. Time is 1.4. Okay. Any more thing? Any more answers? Total time is 1.4, Ravinder, right?
No, sir, 2.8.
Total time is 2.8. So what is 1.4? Total time is 1.8.
So when it reaches the maximum height,
Okay.
till then I will.
Okay, Vmax time. Okay. Makes sense. Yeah. Omer, what is your answer? Omer is sleeping. I will check Omer after this class what's happening there. Okay, max height 10 meter and total time is 2 seconds. Makes sense. Yeah, perfect. Noor Fatima, did you came to a conclusion or no? How about Jawad? Any answers?
I have just,
Yeah, Noor Fatima.
I just total time, which is 1.4 second.
Okay.
But in order to complete whole journey, for the whole journey, we need to multiply it with the 2.
Exactly.
So it would 2.8 seconds. I
Very
was
good.
confused, but I have completed this now.
No, you're right. Actually, you're right. The total time will be 2.8, and the time it will reach the maximum height is 1.4. Yes, exactly. And you find the height as well, Noor Fatima?
Sir, please give me a minute.
Yeah, for sure. Take your time. No worries. Take your time. No, take your time, please. Jawad, yes, go for it.
The height reach is 10 meter, and the time when we use G as 9.8, maximum the time we get is, I guess, 1.43 seconds. And when we combine the both geometries, it becomes 2.8 seconds the total time, and the maximum height is 10 meter.
Perfect. Yeah, lovely. Thank you, Jawad.
Because the motion is symmetrical, that's why we take it 2 times, right?
Yeah, exactly. I will be telling you now how, and just okay. So I got the answers from almost everyone. Yeah, Noor Fatima, I think so. You already gave me the answer, and I'm satisfied with the answer. Okay, let's solve this question now very quickly, and then we move forward with the next one because we need to conclude the class also. Okay, a stone is thrown upward with an initial velocity of 14 meter per second. So I'm throwing a stone upward. Neglecting air resistance, find the maximum height. So simply I need to find the height. Height is simply what? Displacement. Height and displacement are the same. It's just until now we were discussing all about the horizontal, but now we are discussing about the vertical also. It will be same. Okay. So now I know the initial velocity is 0, and now I know that this stone at certain height h, it will become 0. So final velocity will become 0, yeah, because this thing the stone will come again back, and once it is 0, then it will come back. Okay, now we will find this height h. Okay, one second. Now we know very important thing, that acceleration due to gravity, that is g, is 9.8 meter per second square. And now I told you in the beginning of the class, whenever we put the body upward, whenever we throw something upward, the acceleration due to gravity is minus 9.8 meter per second square. Yeah, what's that? Someone told me something.
Yeah, no, I said it's negative then.
Yeah, perfect. Yeah, Alicia, it's negative. Why it is negative? Because it is going in opposite direction. Okay, make sure about this thing.
Yes.
All right, so now we know that acceleration is minus 9.8 meter per second square, and we know the formula again, the same. So the formula which we will be using is v square is equals to u square plus 2as, and now v is equals to u plus 2at. No, why on 80? Because we are not given with the time. That is the reason we are not using that formula. So now v square is 0 square, because final velocity is 0, initial velocity is 14 square, plus acceleration is minus 9.8, and s is what we have to find. Yeah, 14 square is how much? 164 if I'm not wrong. 2 into minus 9.8 is 19.6 meter per second. No, 14 square is what is 14 square? 196.
It's 196.
Yeah.
196.
Why didn't you tell me before? I was checking you guys. Anyways, 19.6 into s, and now is 196. When it goes here, it will become minus 196 is equals to, and you know this thing is in negative because here it was minus 19.6 meter per second square into s. So it will be minus 196 upon minus 19.6 is equals to s, 110. So it will be 10 meter per second square. 10 meter. I'm sorry, 10 meter. Why 10 meter? Because this negative also get cancelled. So that is the reason we don't have minus 10 meter. Okay, that is s. So maximum height attained. Yes, exactly. So yes, you were right, Mohit. It is right. And now we know that height is 10. So we can easily find what we have to find, the time taken. Yeah, so let's find the time. So we have the formula again, v is equals to u plus at. Yeah, so final velocity will be 0, initial velocity was 14, acceleration is minus 9.8 into t. So it will be minus 14 upon minus 9.8 t. Cancel it, you will get it 1.43 seconds, what someone told me. So the time is 1.43 seconds time. and this is only time which is linear. So now the ball will come again back. So that is the reason 1.43 plus 1.43 will be around 2.86, will be around 2.8 seconds. So the total time taken is 2.8 seconds. Clear to everyone?
Yes.
Any questions from any side? No questions. Yeah, perfect. Okay, let's